All right. So this is lecture 2 of these condensed lectures for Electronics 1. The past lecture, if I pull up the lecture notes here, we've seen the semiconductor physics of a p-n junction. We've understood this equation for the built-in potential for the p-n junction, and we've kind of seen the diffusion and drift current and all that stuff, and we kind of have an intuition on how the p-n junction actually works. So now, in this lecture, we're going to move on to analyzing circuits with p-n junction diodes inside of them. Now, like I said in the previous lecture, when you go to your lecture with your professor, the lecture is a 80-minute lecture. So your professor is going to go through a lot of material, a lot of derivation, and a lot of things that your professor will go through might be filler material that will not be tested on or anything like that. So my goal with these lectures is to condense everything into one small package, giving you the content so that you're able to go to a circuit and solve it and have an intuition on how to solve these things. So with that being said, let's move on. Let's hop on to lecture 2. So this lecture, we're going to be analyzing circuits with diodes. That's what we're going to be doing. So in this course, Electronics 1, the most the most amount of diodes you can have in a circuit is going to be 3, okay? You're not going to have more than 3, and I doubt you'll even touch that number 3, maybe on an assignment, but not on a midterm or a final exam. You're never going to have like 3 diodes in a circuit for you to analyze. So we have 3 possibilities. Possibility number 1 is having one diode. And if you have one diode, it has 2 possibilities by itself. That diode can either be on or off. So if I go in the previous lecture and I scroll down, we've said that if you have an ideal diode, it's going to let current flow in the direction of the arrow, right? And if that diode is on, that means a potential is applied right here. That means it's a short circuit, okay? If a diode is on, it's a short circuit, which means it's conducting current. When the diode is off, it's an open circuit because an open circuit, there's no current going through that. So with that being said, if I go over here and if I have one diode that I'm talking about, there are 2 possibilities. It can either be on or off. It can either be a short circuit or an open circuit. Now, if you have 2 diodes, all right, let's say D1 and D2, diode number 1, diode number 2. That means you have 4 possibilities. Both diodes can be off, D1 can be on, off, and D2 can be on. Same thing, on, off, and then on, right? So you have 4 possibilities. 2 to the 2 is 4. So you have 4 possibilities. Similarly, 2 to the 3 is 8, so you're going to have 8 possibilities. Now, looking at this, you might say that this is very, very similar to truth tables that you've seen in Digital Systems 1. Well, it's very similar to that. It's very similar in the sense that you can kind of visualize it as being 0, 1, 0, 1, 0, 0, 1, 1, that type of thing. But like I said, you're not going to go more than 3 diodes in this course. So all the possibilities that are possible here is either on, off, these 4, or these 8. So now, when solving a circuit, let's say you have 2 diodes, for example. You need to pick which combination you want, and then you need to solve the circuit. You cannot know whether that diode is actually on or off. So I want you to listen to me very carefully here. You cannot know whether that diode is actually on or off, so you need to pick. You need to make a guess. Someone can look at the circuit and make a guess and say that D1 is going to be off and D2 is going to be off, and then do analysis from there. So let's say you have a circuit like this. I'm just going to draw something random. Let's say you have a voltage source, you have a diode here, and then diode here, and then maybe a resistor here. Let's say you have, and this is ground. Let's say you have a circuit like that. All right, someone can make the assumption that this is off and then this is off. So that means they're open circuit, and then do analysis from there, okay? Or you can say that one is off and one is on, and then you're going to make analysis from there. So how do we know which combination is correct? How do we know whether the combination that we chose here is correct? Let's say you have a diode here, okay, and you assume it's on. All right, we assume it's on, so it's a short circuit. And if it is on, that means current through flow in this direction, correct? But now let's say you assume that diode is on, it's a short circuit, you're supposed to have a current flowing down in the direction of that triangle. However, when you did your analysis, it says that the current value is negative. That means the current is actually flowing in this direction. Well, that's a contradiction, because if the diode is on, it's going to conduct current in the direction of that arrow, in the direction of the diode, the triangle, that direction it's pointing in. That's the direction of the current. So if you do the analysis after your assumption of it being on, you get a negative current. That means it's flowing opposite to your assumption. So it's a contradiction. That means that diode cannot be on, it has to be off. So, which means that the combination you picked is wrong. That means you have to go back, pick a different combination, and then move on from there. Does that make sense? I hope so. So, with that being said, let's move on to an actual example here. Okay, this is an example with two diodes. It says calculate the value of the current I, which is right here. This is current I, if the diodes are ideal. Now, if I go back to the previous lecture, for an ideal diode, this is our model. Okay, this is going to be a short circuit. This is open circuit. For a real diode, we have a small voltage source right here and in series with a resistor. In our case, it says the diodes are ideal, so we're going to use this one. But if just in case, if they said use the model or the diodes are real, this is the one you would use. Okay, it's not that hard. So calculate the value of the current I if the diodes are real. Now, one thing I want you to notice here is in electronics 1, the way we draw circuits, or more specifically, the way we draw voltage sources, are much more concise and condensed than circuit theory 1. In circuit theory 1, we usually have a setup like this, but in electronics 1, we have a circuit like this, where you just write the node voltage right there for you. But this actually threw me off when I first took that class. I don't know why, I could not wrap my head around that. But one way to look at this thing is this voltage source 5 right here, right, is basically just a regular sort of voltage source that you drew in circuit theory 1. If I want to make this 0.5, this is an equivalent circuit. This one and this one is basically the same thing, but let me prove my point here. So you have this resistor right here, which is 5 kilo ohms. This resistor right here is 5 kilo ohms. This circuit is telling you that on top of this resistor, at this point, you have 5 volts. So that means I can draw a voltage source where this is 5 volts, this is grounded, and then this is going to be 5 volts. I can prove this as well. I'm going to prove it in orange right here. So this voltage, let me call it a point V alpha. Okay? Now this voltage source tells you that if I take the high voltage, the plus side, minus the small voltage, the minus side, I get this voltage. Okay? So 5 volts is equal to V alpha minus 0. So that means that V alpha equals 5. This is basic circuit theory, but in case you forgot and the semester just started, this is a quick review. So V alpha equals 5 volts, just like so. So now, if you look at this circuit, it tells you that this point is 5 volts. So this circuit is the same because this point is 5 volts. Just a quick reminder. Does that make sense? So this part of the circuit is the same as this part of the circuit, but if you have trouble understanding this thing, you can also draw it in this fashion so you have less trouble understanding. Now, let's move on to this part because you have a negative 5 volts right here. I can do the same thing. I can connect a voltage source to ground on the negative side, and the positive side, and the voltage source is going to be minus 5, okay? Now this point has to be minus 5. So let me prove that it is minus 5 so you have an intuition. You could pause the video and try to prove it yourself. It's not that hard because I already did the first one. So this voltage right here, I'm going to call it V beta. So minus 5 volts, or just minus 5 for now, is equal to V beta minus 0. Okay, this voltage is this one minus this one. Okay, so that means that V beta equals minus 5 volts. That's just a node voltage analysis from circuit theory 1, but it's good review. So this is minus 5 volts. And so if you make the comparison to this circuit, this is 5, and then this is 5. I just drawn it as a classic voltage source, and this is negative 5. So this is negative 5 right here. So this is the same thing. We have the same circuit. Now, let me get a sip of my tea right here. Now, like I've said before, you're gonna have to make an assumption on the states of your diodes, right? You have to choose a combination. If I have two diodes, I go to my table right here. These are the 4 combinations I need to pick on. But now your professor is gonna make it seem like there's no way you can get some sort of intuition or make an intelligent guess. Actually, intelligent guesses can be made through experience. And I've solved a lot of circuits taking this course myself. And when I look at the diode circuit, I have better odds on picking the right combination because I don't want to spend a lot of time picking the wrong combination, doing analysis again until I get the right answer. So I want to pick the right one right away. And one way I can do that is just by looking at this sort of circuit right here. Because in the previous lecture, as I've said, is if a diode wants to conduct current, this has to be the higher potential, this has to be the lower potential, and the current will flow in this direction. So similarly, if I look at this circuit right here, I can see that this is 5 volts, this is negative 5 volts. So this is high voltage, high potential. This is low potential, okay? Current flows from high to low voltage, right? When you have high voltage, low voltage, current's going to want to flow from high to low voltage. That means there's going to be a general current flow going like this in this circuit, right? The current's going to want to flow down. And if the current wants to flow down, that means this potential is much higher than this one, and this potential is much higher than this one. So these two diodes are going to want to conduct current in the direction of their triangles. So that means the two diodes has to be on because a current is going here and a current is going here. Now, one more way you can kind of see that a current these two diodes are going to be on is because in the question it already gave you that the current I is flowing down, right? If the current I is flowing down, that means D1 has to be on. So that's a given. That's how you can kind of like click and then make the right guess right away. But now, if you look over here, you sort of have a current flowing down and a current, this one has to be on. So the other current naturally has to flow down because this is high and then this is low. That's another way to see things. So that's why I made the assumption that D1 is on and then D2 is on. And since both diodes are ideal, D1 and D2 are short circuits. So what I'll do is I'll redraw this circuit right here by replacing these diodes by short circuits. So this is what I have now. Now just forget about this for a second. Let's look at the circuit and get some intuition from it. So over here, the two diodes, they're right here, but they're now short circuits. Now, of course, you can just draw a line right here as representing short circuits, but me, I like to put these dots right here like this, representing my short circuits like that. The way I like to do this is in case I made a mistake, I will remember that I replaced a diode here by a short circuit, so I can easily debug if in case I made a mistake. So anytime I do a short circuit, I kind of put these dots, so I remember that something was there initially, but I had to make the change to a short circuit. Now, when you look at this circuit, we want to find this current I. If you look over here, the highlighted in yellow, right? This is all the same point, right? This is connected to voltage ground, and this is just a wire right here. So this is all the same point. It's the same electrical point. So this point is ground, all of this is ground, ground, ground. And since V is connected to this point right here, this is V, so V is also ground, okay? So this point right here is ground, V equals 0. This point, we proved that it's 5 volts. This point, we've proved that it's negative 5 volts. Hence, since this one is just one point, that means I can do a KCL at this point in red that I'm lasering right now. This point right here, I can do KCL right here. We got a current flowing in, we got I coming here, and then we got another current flowing here. The current flowing in is going to be 5 volts minus 0 over 5 kilo ohms. 5 minus 0 over 5,000. That's my first current. And then we have two currents flowing out. Current flowing out, the first one is our unknown I that we want to find. And the second current flowing out is going to be 0 minus 5 over 10 kilo ohms. Okay? 0 minus 5 over 10 kilo ohms. So that's going to be 0 plus 5 over 10,000 ohms. So we have this equation right here. Now, I is what I want to find, so I'll send this to the other side of the equation. It's just basic algebra. I do this calculation and I get my current. So that means that my current is 0.5 milliamperes. Now, if I look at the circuit and I look at my current I, all right, I look at its value, it's positive. That means the current is going in this direction. So I'm very happy. The reason why I'm very happy is because the diode is conducting current in the direction it's supposed to be conducted. Say, for example, I had minus 0.5. This answer would be wrong, okay? I would have to choose a different combination and do analysis again because it does not agree with the assumption that I made, okay? If you look at this current right here, 0 minus 5, which is 5, over 10 kilo ohms is also positive. So that means this current flowing through this diode is also positive. So this diode right here is also conducting current in the direction it's supposed to. So this is how we solve a circuit with multiple diodes in it. So and how we can make smart smart guesses based on the states of the diodes, right? Which combination is it, on off, stuff like that, how we can make smart derivations and kind of understand how they work. So one piece of advice I would leave with you here is try to look at the voltages in your circuit. Try to see the high voltage and the low voltage. It's kind of going to give you an intuition on the state of your diode, right? If you have high voltage here, low voltage here, and if you have a diode pointing down, the diode is most likely to be on. Okay, so that's one thing. And one more thing is, in electronics one, when you're solving circuits or you're solving a problem, when you solve it and you get the right answer, don't just leave the circuit there and then move on to the next problem. Problems in electronics one are very repetitive. The only thing that changes are minor things, resistors here and there, stuff like that. Okay? Or topologies, different things like that. So what you need to do is, when you solve a circuit, look at that circuit and ask yourself, what did I learn from this? Or for example, from this circuit, you can say that, oh, I learned that I can make smart guesses about my diodes, right? I learned that I can look at the high voltages and low voltages of my circuit. So stuff like that. So when you solve a problem, after you're done solving it, take 5 minutes, look at it, and try to gain a better insight on it. Not mathematical insight, circuit topological insight. So when you look at a circuit, you kind of have an intuition on how you can approach solving that circuit, because you've solved one in the past that kind of looks like the one you're solving right now. So with that being said, I hope this video was very helpful. And this is the more fun part, in my opinion, of electronics, where you're actually solving circuits and not worrying about the physics so much, because the circuits is actually what's important in that course. Okay, so with that being said, this is the video for lecture 2. Um, I hope that I'm gonna be posting lectures more regularly. I was a little bit busy with the holidays, Christmas, and then New Year's. Been celebrating too much, but let's hope that I post these videos a little bit better and more regularly. So with that being said, thank you for your attention. And if you want to see more videos from a unconventional small YouTuber, click on that subscribe button and like this video. Thank you very much.